Hi everyone. I'm going to present my work on data efficient training strategies for neural TTS systems. Well, why do we need TTS systems? Well, here are three example applications. One is a German TTS lecture video, an automatically dubbed movie scene, and a dubbed TV interview using a Hindi TTS. So, with the increased interest in making content accessible across languages, TTS systems can play a key role in synthesizing the new speech. They can also be used for browsing websites and in audiobooks. Thus, they're definitely the need of the hour, and we need TTS systems in a large number of languages, accents, and voices. Our work is on focusing on the developments in the Indian language scenario. So there are 19,500 Indian languages with 720 dialects, and the initial efforts to build TTS systems for these languages was first by IIITH Indic Speech Database, where they collected 1 to 2 hours of data in 7 Indian languages. Also, IIT Madras collected high quality corpus for 13 Indian languages, and they also built accurate TTS models for these languages. Recently, neural TTS models were released for English, which were able to produce natural speech, such as Tacotron 2 and Deep Voice 3. But the main limitation is that they require 24 hours of data to train to produce natural speech. So, for the Indian language scenario, none of the corpuses, at least some of the major corpuses, do not have that much amount of data. And 24 hours is definitely limiting given the large number of languages. The goal of this work is to train neural TTS models with just 2 hours of data. So, how do we do this? Well, uh, obviously, if you're training from scratch, we would definitely need that much amount of data. But we know that it is much more scalable to just collect 1 to 2 hours of data, and the idea is to not start from scratch and perform pre-training and then be able to train with just 1 to 2 hours. So where do we get the data to pre-train with? Well, one possible source is to automatically obtain the annotations. For example, if you have noise-free speech, you can just run an ASR and get the corresponding text. Another thing is to perform simple fine tuning, train on one speaker and just fine tune on another one. The third is, can we just perform multilingual training, pool the data across many languages speakers, and then train on all of them together? Let's explore one by one. So the first strategy, free for all, because this requires minimum manual effort, where you just have to download audiobook recordings from YouTube, automatically segment them using an automatic voice detection pipeline, and Google run an ASR, a standard ASR. We use the Google ASR and get the corresponding text. This text can have mistakes, but then recent efforts have shown that if we have a large amount of data, a little bit of noise can be handled by the TTS system. So we pre-train our TTS using this synthetic prayer data. The other strategy is the one for all strategy, where you train on, let's say, a major language, let's say Hindi, on 24 hours of single speaker Hindi, and then fine tune for other languages. We exploit the fact that phonemes are shared across these languages. For example, the word per is shared across so many languages. And if we represent them using common Roman script, we'll be able to transfer across languages and speakers. This last strategy is the all for all strategy, where we simply take two, instead of 24 hours in each language and speaker, we are able to take 2 hours of from different languages and speakers, pool the data together, and train a single multilingual multi-speaker TTS. And once we pre-train, well, again, we use the fact that all these languages share can be translated to common Roman script. And after pre-training, we just fine-tune on a specific language to improve the performance on that further. And here are the results of this. The all for all strategy worked best. We fine tune on the IIT Madras speech corpus after pre training. Use the Deep Voice 3 model. So here are some results in different languages, all of them using just 2 hours of data.
यह आशावाद का एक बड़ा और दोस्त था.
బియ్యాన్ని సేకరించి అవసరమైన ప్రజలకు పంపిణీ చేస్తామన్నారు.
இதை பற்றி மக்களிடம் சொல்ல உங்கள் அனைவரையும் நான் கேட்டுக்கொள்கிறேன்.
ಅಮೆರಿಕದಲ್ಲಿ ಅತಿ ಹೆಚ್ಚು ಕೊರೋನಾ ಪ್ರಕರಣಗಳು ಪತ್ತೆಯಾಗಿವೆ.
मात्र सगळेच काही सुरळीत पार पडलं. বিস্ফোৰণৰ ফলত কাষৰীয়া অঞ্চলৰ ঘৰদুৱাৰৰ ক্ষতি.
ପ୍ରଶାସନ ପକ୍ଷରୁ କରୋନାକୁ ନେଇ ପାଳନ କରାଯାଉଥିବା ଗାଇଡଲାଇନ୍ସ ସ୍ୱାଗତଯୋଗ୍ୟ.
স্বাস্থ্য এবং নিত্য প্রয়োজনীয় জিনিসপত্র ছাড়া যাবতীয় সব পরিষেবাই বন্ধ।
So, to summarize, we presented 3 pre-training techniques that enable state-of-the-art neural TTS systems to adapt with just 2 hours of data. And we showed that we can exploit common features across languages and train more robust natural TTS systems. So here is a cool application which was enabled using a
తెలియదు.
model.
Another use case would be to translate and deliver important public messages to people all over the country.
What better day for a conference to take place on one of the oldest industries in the country than the National Science Day.
राष्ट्रीय विज्ञान दिवस की तुलना में देश के सबसे पुराने उद्योगों में से एक सम्मेलन के लिए क्या बेहतर दिन है।
మరియు జాతీయ విజ్ఞాన దినోత్సవం కంటే దేశంలోని పురాతన పరిశ్రమలలో ఒకదానికి సమావేశం జరగడానికి మంచి రోజు.
Thank you.